Why Moon's South Pole is important. Before we move in, don't forget to like and subscribe. The South Pole of the Moon contains a region known as the South Pole Aitken Basin, which is one of the largest and oldest impact basins on the lunar surface. The South Pole Aitken Basin on the Moon is an enormous impact crater that dates back to the early history of the solar system. It's named after two nearby features, the lunar South Pole and the Aitken crater. This basin is approximately 2,500 kilometers, 1,550 miles, in diameter and about 13 kilometers, 8 miles, deep, making it one of the largest known impact basins in the solar system. The basin is characterized by its relatively flat floor, which is covered by a layer of ancient lunar crust. This crust has been estimated to be around 4.5 billion years old, making it one of the oldest surfaces on the Moon. The impact that created the South Pole Aitken Basin was so powerful that it excavated material from deep within the lunar crust, exposing material that wouldn't otherwise be visible. One of the most intriguing aspects of the South Pole region is the presence of permanently shadowed craters within the basin. These craters are located in areas where sunlight never reaches due to the angle of the Moon's axis. As a result, these regions remain extremely cold, with temperatures dropping as low as -250 degrees Fahrenheit, -157 degrees Celsius. Scientists believe that these shadowed areas could potentially harbor deposits of water ice and other volatile compounds. The presence of water ice in these permanently shadowed regions is of great interest to space agencies and researchers. Water is essential for sustaining future lunar exploration and potentially supporting human colonies. Extracting water from these icy areas could provide drinking water, oxygen, and hydrogen for fuel. Various lunar missions, including orbiters and landers, have been studying the South Pole region to better understand its composition, topography, and the potential resources it may hold. Additionally, there are plans for future missions that aim to explore these shadowed craters in more detail, seeking to confirm the presence of water ice and assess its potential usefulness for future lunar activities. Why is it hard for countries to land in the South Pole? Landing at the lunar South Pole presents several challenges for space missions due to its unique characteristics and environmental conditions. Number 1. Permanently shadowed regions. The South Pole of the Moon has areas that are in permanent shadow, resulting in extremely cold temperatures. These shadowed regions can drop to temperatures as low as -250 degrees Fahrenheit, -157 degrees Celsius, making it difficult to design and operate equipment that can withstand such extreme cold. Number 2. Communication difficulties. Because of the Moon's rotation, the South Pole is often out of direct line of sight from Earth-based communication stations. This can lead to communication delays and intermittent contact with spacecraft, making real-time control and data transmission more challenging. Number 3. Rough terrain. The South Pole terrain is rugged and uneven, with numerous craters and boulders. Finding a suitable landing site that is both safe and relatively flat can be challenging, and precision landing becomes crucial to avoid hazards. Number 4. Limited sunlight. The long periods of darkness in the permanently shadowed regions can limit the availability of solar power. Spacecraft and landers often rely on solar panels to generate electricity, and the lack of consistent sunlight can affect their operations. Number 5. Lack of visual references. The landscape at the lunar South Pole can lack distinct features that provide visual references for navigation. This makes it harder to accurately navigate and avoid obstacles during descent and landing. Number 6. Dust and regolith. Lunar dust and regolith, loose surface material, can pose challenges during landing. The fine dust particles can be abrasive and interfere with equipment, potentially causing damage to landing gear, sensors, and other sensitive components. Number 7. Harsh radiation environment. The lunar surface is exposed to harsh radiation from the sun and cosmic rays due to the lack of a protective atmosphere. This can pose risks to both spacecraft and any potential human occupants. Number 8. Resource limitations. Given the challenges of landing and operating in the South Pole region, missions require careful planning and robust systems to ensure success. This often translates to higher costs and technical complexity. Despite these challenges, space agencies are actively working on developing the technology and strategies needed to land successfully in the lunar South Pole region, including Chandrayaan-3 and Luna 25. The potential resources, such as water ice, make it an attractive destination for future exploration and could play a vital role in sustaining long-term lunar activities. What differentiates South Pole from other parts of the Moon? In short, there are a lot of things. Let's see. Number 1. Permanently shadowed regions. The most significant distinction is the presence of permanently shadowed regions within craters at the South Pole. These areas never receive direct sunlight due to the Moon's tilt and the terrain's topography. This has allowed water ice and other volatile compounds to accumulate over billions of years, which are believed to have been deposited by cometary impacts. These volatile materials are not as prevalent in regions that receive sunlight, making the South Pole a potential source of valuable resources for future lunar exploration. Number 2. Water ice. The permanently shadowed regions are of particular interest because they are hypothesized to contain water ice. Water is a critical resource for sustaining human presence on the Moon, as it can be used for drinking, as a source of oxygen and hydrogen, and for generating rocket fuel. The presence of water ice in these shadowed areas could potentially provide a sustainable source of water for future lunar activities. The Moon's South Pole contains water ice in the form of deposits found in the permanently shadowed regions within craters. These areas are extremely cold and never receive direct sunlight, allowing water ice to accumulate over billions of years. Number 3. Ancient impact basins. The South Pole is home to some of the Moon's largest and oldest impact basins, including the South Pole Aitken Basin. These basins are unique geological features that offer insights into the Moon's early history and its formation. The basin's topography and material composition can differ from other regions of the Moon. Number 4. Extreme cold and long darkness. The South Pole experiences long periods of darkness due to its unique orientation relative to the Sun. This results in extremely cold temperatures that can reach as low as -250 degrees Fahrenheit, -157 degrees Celsius. The harsh cold and darkness present challenges for any equipment or infrastructure that needs to operate in this environment. Number 5. Scientific interest. The South Pole's unique conditions make it an ideal location for scientific research. The study of the permanently shadowed regions can provide valuable information about the Moon's history, the processes that shaped its surface, and the interactions between the Moon and the space environment. Why countries and agencies want to explore this area? Exploring the Moon's South Pole offers several compelling reasons for countries to invest in scientific missions and potential future activities in this region. Let's have a look at the reasons. Number 1. Resource potential. The presence of water ice in the permanently shadowed regions at the South Pole holds significant value. Water is essential for sustaining human presence in space, as it can be used for drinking, generating oxygen and hydrogen for life support and fuel, and potentially supporting future lunar colonies. Number 2. Scientific discovery. The Moon's South Pole provides a unique window into the early history of the solar system. Studying the ancient impact basins and geological features can help scientists understand the processes that shaped the Moon and its relationship to Earth. Number 3. Technological innovation. Exploring the challenging environment of the South Pole requires the development of advanced technologies, from precision landing systems to thermal protection for extreme cold. These technologies can lead to advancements in space exploration and have spin-off applications on Earth. Number 4. International collaboration. Collaborative efforts among countries can promote global cooperation in space exploration. Sharing resources, expertise, and data from South Pole missions can lead to a more comprehensive understanding of lunar processes and the broader universe. Number 5. Inspiration and education. Lunar exploration, particularly in a challenging area like the South Pole, can inspire the public and ignite interest in science, technology, engineering, and mathematics (STEM) fields. This can encourage the next generation of scientists, engineers, and explorers. Number 6. Preparation for future missions. The Moon's South Pole can serve as a stepping stone for future deep space missions, such as those aimed at Mars. Developing technologies, strategies, and infrastructure for lunar exploration can provide valuable experience for more ambitious space endeavors. Number 7. Long-term sustainability. Establishing a sustainable human presence on the Moon requires developing local resources. The water ice at the South Pole can potentially serve as a source of life-supporting elements, reducing the need to transport supplies from Earth. Number 8. Commercial opportunities. The potential for resource extraction and scientific research can attract private companies to participate in lunar exploration. This can stimulate economic growth and create new opportunities for commercial space ventures. Thank you for watching. Like and subscribe.